Everyone. Today's discussion is actually on probability distribution function and probability density function. But before we move into that part, I would like to draw your attention on discrete random variable and continuous random variable. As we know, probability is often associated with an event, and the outcome of the event is not, or it is a random variable. Say, for example, we want to play with a die. So the outcome of the die might be anything. So it's a random variable. Now, if that outcome is discrete in nature, it is not continuous. That means for any two consecutive value, we won't be able to find any other values, then it will be very discrete in nature. So in that case, that random variable is termed as a discrete random variable. But in case of if it is having any continuity, then it will be a continuous random variable. Now, for any discrete random variable, the distribution function we use, that is actually the probability distribution function. But in case of the continuous random variable, the probability distribution function is, or the distribution function is termed as a probability density function. Now, say for example, how we calculate or how we will represent that probability distribution function. Say for example, in case but before we go into that discussion, we have to know what are the notations. Normally, P is termed as a probability, and capital X represents the random variable, and small x represents all the values of the random variable. Now, if here f is actually the discrete, f is actually the probability distribution function which plays on the discrete random variable. So f can be defined like that: for all values of x, small x, which actually lies in capital X, fx should be greater than equals to 0, and summation of fx equals to 1. So summation, this is very important thing. Like we are using summation here because we are not using integration here. We are not using integration operator here because it is not a continuous function, it is a discrete function, so we cannot do integration. Now, say for example, we have an example 1 for x, as we have seen, like this is the value. So for this value, the probability is this. So if we can draw it into a graph, and we can get this point for 1, this point for 2, 0.3, this point for 3, and this point for 5. Now, how we define the probability distribution function here. Now, if we want to go for random variable, we have to take help of histogram. Now, histogram, what it says, like for this is x-axis, that means it represents all the variable, it will represent all the variable. Now here the variable is random variable, so the value of random variable comes from 1 to 5. So for every, what we have taken here, this is 1, so we go here and the length of this block will be 1, the length of this block will be 1, the length of this block will be 1. So here the point 1 will be the middle will be the middle of this. That means this will be 0.5, this will be 0.5. Similarly, this will be 0.5, this will be 0.5. So the total length of this section is 1, and here it is 0.1, as we have seen. So the area of this thing will be 1 into 0.1, that means 0.1. The area of this thing will be 1 into 0.3, so that means it will be 0.3. So this is area we are representing. This is again 1, and this is 0.4. So 1 into 0.4 will be 0.4. Why we are interested on area? we are coming into that. So that will be clear when we will come into this random variable stuff. So in case of random variable, the density function similarly, as it is a continuous function, so the density function will be the area of integration of a to b, where definitely b greater than a and fx greater than equals to 0, and the summation under this curve, area of this curve will be 1, fx dx equals to 1. Say for example, we have taken a function like a into e to the power minus ax, where x greater than is equal to 0. For x greater than is equal to 0, we are getting the curve. For x less than equals to 0 or anything, it will be 0. So the curve is not present. Now if we want to calculate the integration over a to b, then it will be this part. So actually we are getting an area here, right? So if we simulate the same concept in case of random variable, then we need to take the help of histogram, and we have to very tactically find out the area, and histogram helps us to get that area. And I mean, where we have chosen one length as 1, and another part is the value of the probability, so the area will be like the same, correct? Thanks for watching this video. Bye guys.